Welcome students, welcome to TKG classes. So in previous class we discussed about the basic thing about light. That is, at first we learn reflection of light, then we learn the laws of reflection, then we study the types of mirror and its application, and then there are image formation, rules for formation of image by concave and convex mirror. After that we study mirror formula, linear magnification and some numericals related to it. Now in this lecture we study the second part of light, that is we have to study here refraction of light. So what is refraction of light? Right? Refraction of light. So to study it, at first we have to know two things, that is what is opaque object and what is transparent object. Transparent object. In this case, light cannot travel. Okay, and the example is, suppose wood, কাঠের কোনো light travel করতে পারে না, iron, bricks, etc. And what is transparent object? In transparent object, light can travel easily. Okay, and in this case, light traveling in a straight path. Light follows a straight path. And the example of transparent object, that is air, glass, water, etc. So what is opaque object? That is, in this case of opaque object, light cannot travel, and in case of transparent object, light easily travel. Now in case of transparent object, light easily travel, but if we consider two medium, suppose this is medium air and this is glass, this is medium 1, this is medium 2, and this is the surface between two medium, that is interface, or you may call it is surface. Suppose a ray of light, that is OP, incident here at the surface at point P. So this is called incident ray. Okay, now what is the nature of light? If there is no change of medium, light can travel this way, but as there is another medium, that is glass, so here at first you draw the perpendicular bisector, that is called the normal, which is learned in previous class. This is the angle of incidence, the angle between normal and the incident ray. Here light bends like this. If there is no change of medium, light travel like this way. As there is change of medium, so light bends like this. So this is the refracted ray, and this angle is called the refracted angle, which is denoted by symbol R. Clear? In this case, what happened? That is, when light travels one medium to another medium, light easily bends. This bending phenomena of light, when light travels one medium to another medium, is called the refraction of light. Refraction of light টা কি? That is, light যখন একটা মিডিয়াম থেকে আরেকটা মিডিয়ামে ট্রাভেল করছে, লাইট বেন্ড করে যায়, স্ট্রেট পাথ ফলো করে না। তাহলে the bending of light when it travels one medium to another medium is called refraction of light. Now we have to know another thing, that is what is a refractive index. So what is refractive index? The refractive index, to study refractive index, at first we have to know that light travels in a vacuum. For changing medium, the speed of light changes. The speed of light in vacuum, the value is maximum, and this value is 3 into 10 to the power 8. Clear? And the speed of light, for suppose the speed of light in glass, that is 2 into 10 to the power 8. This is meter per second unit of speed. So light travels in a vacuum, that in the speed of light in a vacuum, that is the maximum, and for changing medium the speed of light changes. Now refractive index, which is denoted by symbol n or mu, refractive index which is denoted by symbol n or mu can be written as, refractive index can be written as speed of light in vacuum divided by speed of light in any medium. Okay, so refractive index is the ratio of two speeds. As refractive index is the ratio of two speeds, so what will be the unit of refractive index? Unit of refractive index, what will be the unit? This is the unit of speed, that is meter per second. This is also meter per second. So meter per second cancel out. It has no unit. Clear? Then what will be the dimension? The dimension of speed, that is LT minus 1. Clear? Which is in details in class 11. And the speed of, this is also speed of light, there is speed, the dimension LT minus 1. So this is cancel out. So there is no dimension, m to the power 0, l to the power 0, t to the power 0. Clear? So refractive index has no unit and no dimension. And what is refractive index? That is, refractive index is the ratio of speed of light in a vacuum to the speed out of light in a medium. Suppose you have to calculate refractive index. Refractive index mu for glass. So what will be the formula? That is, at first we have to write the speed of light in a vacuum, that is 3 into 10 to the power 8. Then the speed of light in a medium, and here we calculate the refractive index for glass. So this lower portion speed will be the speed of light in glass, and this value is 2 into 10 to the power 8. Cancel out, that is 3 by 2, which is approx 1.5. Clear? Suppose we have to calculate refractive index for water. What will be the value? Same case, in upper portion the speed of light in a vacuum, that is 3 into 10 to the power 8 divided by, in lower case we have to calculate the speed of light in water, and this value is approx 2.25 into 10 to the power 8. Simplify it. So this is the value of refractive index for water. Clear? So what is refractive index? It is not this very tough thing. It is a ratio of two speed of light. Upper portion is vacuum and lower portion is in medium. Now, depending upon the refractive index of light, we have three special cases. That is, in any medium can be classified in two categories. That is, optically denser medium, okay, and another one is, that is, optically rarer medium. The question is, when a medium is said to be denser and when a medium is said to be rare. Suppose the refractive index for air around equivalent to 1 and for glass which is equivalent to 1.5. Just check. Here refractive index 1, here 1.5. So which one greater? Obviously glass. So among two medium which has more refractive index, this medium is called denser medium. And among two medium, which medium has less refractive index, this medium is called rare medium. Clear? So what is the denser, optically denser medium? Among two medium or between two medium higher refractive index is called denser. So here denser is glass denser medium with respect to air, and between two medium, the medium which is lower refractive index is called a rare medium, and here lower refractive index is air. So air is rare medium car respected with respect to glass. So this is all about medium. So medium categorized in two categories, that is optically denser medium and another one is optically rare medium. Which medium has higher refractive index, that is called denser medium, that is dense, and which medium has lower refractive index, that is called the rare medium. Clear? Now depending upon medium, the refraction of light, that is the bending phenomena of light, are categorized. Okay, so there are three cases for bending of light. If light travels, case 1, that is if light travels rare to denser medium, what will happen? Just write rare medium to denser medium. So this is air and this is glass, suppose. So here rare medium, this is the denser medium. Clear? Because the refractive index of glass is more with respect to air, and this is the surface interface, light incident here. So at first we have to draw perpendicular bisector, which is called normal. Clear? This is the incident ray, this is the angle of incidence, and here light travels rare to denser. In this case, light will goes, if there is no change of medium, light goes like this way. But if light travels rare to denser, it will bend towards the normal. This is the normal. The light bends towards the normal. Clear? This is the refracted ray, and this is the angle of refraction. Now case 2, that is when light travels denser to rarer medium. That is when light travels denser to rare medium, the phenomena just reciprocal to previous one. Suppose this one is glass and this one is air. The incident ray, this is the normal, angle of incidence. Here if there is no change of medium, light goes like this way, but medium changes and this is denser, this is rare medium, so light will goes away from the normal. Okay, this angle is R. Light goes away from the normal, that's why here R is increasing, R is more with respect to I. Here R is greater than I. And first case, here light bends towards the normal. This is the normal, light bends towards the normal. So this value, that is R, is less than, that is I is greater than R. Clear? Now case number 3, that is there is special case. Okay, and this case is when light incident normally at the surface. then what will happen? This is the surface and this is the incident ray. Incident ray. And what will be the normal here? Normal is always drawn at the point of incidence in perpendicular. So the normal is also represent this line. That is, in this case, incident ray and normal lie parallel, same. So what is the angle between them? There is no angle, that is theta is equal to 0. This is the incident ray and this is the normal, parallel to each other. So this is the theta is equal to 0, and in this case the refracted ray will be like this, that is will passing through this normal, and here also the angle of refraction R is 0. So there is no bending phenomena of light. This is a special case. Clear? So light travels, that is the bending phenomena of light. When light travels one medium to another medium, it depends upon in which medium light travels. When light travels rare to denser medium, it bends towards the normal. When light travels denser to rare medium, it's away from the normal. And when light travels, that is when light incident normally, then there is no bending, that is angle of incidence I is equal to 0. Okay, so then we have to calculate, or we have to learn, that is refraction, laws of refraction. Similarly, in previous lecture we learned laws of reflection. Here we have to learn laws of refraction. First point, incident ray, refracted ray, and normal at the interface between two transparent medium at point of incidence lies at same plane. This is the first point. And the second point, the sign of the angle of incidence, that is sin I, and to the sign of the angle of refraction, that is sin R, is constant, always constant, and this constant is called refractive index of medium 2 with respect to medium 1. That is, sin I, mathematically it can be represented by sin R is equal to mu 2 with respect to mu 1. So it represents as mu 2 by mu 1. That is refractive index of medium 2 with respect to medium 1. Clear? So this is the laws of refraction of light. First law, incident ray, refracted ray, and the points of incidence. This one, incident ray, normal, and the refracted ray. And at the point of incidence, both are lies in the same plane. And the second case, that is sine of the angle of incidence to the sine of the angle of refraction, is always remains constant. Now let's take one example for refraction of light. Suppose we consider a glass slab. Okay, so this is the glass slab, glass, outside medium air, and there is also medium air. Now a ray of light incident like this at the surface AB. This is the incident ray. Now make a normal, that is perpendicular. Now as light travels air to glass, that is rare medium to denser medium, so it will be bends towards the normal. So light bends like this way towards the normal. Clear? Again here light incident at the surface CD. Now check here, again you draw normal. Now light travels glass to air, that is denser to rare medium, so it will be away from the normal, that is away from the normal, that is refracted ray. Just check it, if incident ray goes like this way, this is the original direction, but due to refraction light bends and light finally goes along this path. Clear? Here this perpendicular distance is represent lateral displacement, and this is the refraction, and light bends here due to refraction of light. First case light travels rare to denser, that's why light bends towards the normal. Second case light travels denser to rare, that's why light goes away from the normal. And finally, if we draw the final refracted ray and the original incident ray direction, then this perpendicular distance is called lateral displacement. Okay. So in this class we learned, that is the basic thing, what is refraction of light, laws of refraction, refractive index, then what is denser medium, rare medium, what will happen when light travels from denser to rare, what will happen when light travels from rare to denser, etc. In this class, this is all about this class. Next class we will discussing about lens and the image formation for lens, rules for ray diagram for lens, and etc. So stay tuned. Thank you.